Hello! I'm here again for you to have additional video for our new topic, for you to gain knowledge of our new topic, which is simplifying rational algebraic expressions. But before we proceed, I have to recall to you what is a rational algebraic expression. So we have to take note that rational algebraic expression is always written in the form of fraction. Because if we are going to base on its definition, rational algebraic expression is the ratio of two polynomials. So you have to take note that our numerator and our denominator are in the form of polynomial. So therefore, they may be monomial, binomial, or trinomial. And then you have to take note that our denominator q is not equal to 0 for you to remain them as rational algebraic expression. Okay? So to proceed, let us have simplifying rational algebraic expressions. If we are going to have monomial and binomial, so we have to apply what we have learned on how we are going to simplify fractions. Okay? So for example, I have given you 4 over 6. For example, I told you to reduce this to lowest term. So what are you going to do? Right, you are going to find for the GCF. So the GCF of 4 and 6 is 2. Therefore, you are going to divide the numerator by 2. So you will have here 2 over divide again the denominator by the GCF 2. So you will have here 3. Therefore, you already have the simplest form of 4 over 6, which is 2 over 3. So now, we are going to have rational algebraic expressions. And for you to simplify them, you are going to apply or recall the topics that we have before. We have the rules and operations of integers, which was taught on your grade 7 lessons, and also with the laws of exponents from your grade 7 lesson also. And then, the different factoring techniques that we have last week. Okay, so let us have an example of polynomial or rational algebraic expression wherein the numerator is a monomial and the denominator is also a monomial. For example, I have here 6x squared y all over 12xy cubed. Okay. So there are two methods on how you are going to simplify this. So let us have first the long method. So, wow, it's too long. Okay? The line is too long. So we have here to factor out first the numerator. So, you have to take note that if you are going to factor out, you are going to have the prime factors. Okay? So, prime factors are numbers, or prime numbers are numbers wherein they have no other factors except 1 and itself. So, 3 and 2 will be used as the prime factors of 6. And then, to factor out x squared using the law of exponent 2, so you will have your times x. And then we only have the exponent of y is 1, so that's why you only have here y. All over, we have here to find for the prime factors of 12. So we have here 3 times 2 times 2. So it is 12. Times x times y cubed means y times y times y. And then, after factoring, you are going to divide out the common factors. So, you will have here 3 divided by 3 will become 1. 2 by 2 is 1. Then, x divided by x is 1. Then, y divided by y is also 1. So, on the numerator, we have left with 1 times 1 times 1 times x times 1. So, your answer here should be x over... So, we have here on the denominator, let me remove this. So, on the denominator, we have 1 times 1 times 2 times y is equal to 2y squared. So, that's why the simplest form of this is x over 2y squared. So, that is with the use of the long method. But if you are going to use another method, if you already mastered yourself on how you are going to find for the GCF, applying the law of exponent, there is another way, or shorter way, on how you are going to simplify this. Using the same given, you may take note first of the numerical coefficients here. So, we have 6 and 12. You are going to find for the GCF of this. So, yes, the GCF of this is 6. So, 6 divided by 6 will be 1. And 12 divided by 6 is 2. So that's why in our solution here, you will have here 1 and you will have here 2 on the denominator. Referring to the variable, so we have here x on the numerator and x on the denominator. But on the numerator, we have x squared and then x on the denominator. So applying the law exponent, if you are going to divide them, copy the base and then subtract the exponent. But in this case, you have to take note, where is the higher value of your exponent? Since we have the higher value of the exponent in the numerator, which is 2 rather than 1, so you will have here x and then subtract the exponent. So 2 minus 1 is 1. So you do not have to write 1 here. It is already understood that your exponent there is 1. And then, in terms of the variable y, you are going to apply also the law of exponent. So we have here copy the base and then subtract the exponent. So you can have here as our scratch on the lower side, we have here y over y cubed. And then you will have here to copy the base and then subtract the exponent. So 1 minus 3 is negative 2. But we have the law of exponent that any expression raised to the second power or raised to negative power is equal to 1 over its reciprocal. So again, we have a raised to negative n equals 1 over a to the n power. So that's why this y raised to negative 2 will become 1 over y squared. So therefore, we have here 1 times 1 over y squared. Then simplify. So you may also have here 1 times x times 1. So you will have your x over 2 times y squared is 2y squared. So still, you have the same answer. Or sometimes, I am telling my students to have that technique on how you are going to find for the simplest form simply by finding the term with the greater exponent. For example, I have here again 6x squared y over 12xy cubed. So you are going to have here, okay, so you have here equals. Then again, just like what I have done earlier, the GCF of this is 6, so it will become already 1 over 2. And then look for the variable with the greater exponent wherever the variable with greater exponent deal. So that is the part of the fraction that you have to write your variable. So dito, mas mataas ang exponent ng x sa numerator, kaya yung x ay sa numerator natin ilalagay. And then on the variable y, mas mataas ang exponent sa baba, sa denominator, kaya meron tayo dito ang y. Then, kung imaginein mo, using the long method, may dalawa kang matitira dyan. So, may square ka dyan. And then, 1 times x, again, is x over 2y square pa rin. Okay? So, I hope you understood the long method and the shorter method. Okay? And then, let's proceed with another example. So, I have here 48a cubed b to the 5th power over negative 12a squared b cubed. So, this time, let us have the shorter method, I think, so that we can push the shorter method. So, we have here 48 and negative 12. Find the GCF. So, the GCF of them is 12. So, 48 divided by 12 is 4. And negative 12 divided by 12 is negative 1. So, that's why we have here 4 over negative 1. And then, the variable a, you have the greater exponent on the numerator. So, you have here a. Then, 3 minus 2 is 1. So, that's why we have here 1. But again, you do not have to write 1 as your exponent. And then, in terms of the variable b, so it has the higher exponent on the numerator. That's why you will have your 5 minus 3 is 2. But since our denominator is only 1, so you may perform your operation here with the integers. Part divided by negative 1 is negative 4. Then times a times b squared. So that's why your simplest form is negative 4ab squared. Okay? So let us have another example. I hope you don't have your questions. Again, if you have your questions, do not hesitate to chat or call me or text me. Okay? So let us have 125m to the 5th power n cubed divided by or over 20m square n square. So this time, again, you have to find for the GCF of 125 and 20. Yes, their GCF is 5. Then 125 divided by 5 is, yes, 25. Then 20 divided by 5 is 4. So you will have here 25 and 4. Then in terms of the variable m, so the higher exponent is on the numerator. So that's why you have the variable m on the numerator. And then 5 minus 2 is 3. And then in the variable n, we have the higher exponent on the numerator. So we have here n, and then 3 minus 2 is 1. So again, 1 as your exponent should not be written or will not be written. So that's why you already have your simplest form here, 25m cubed and all over 4. Okay? So how about if you are given monomial on the numerator and binomial on the denominator? So let me have 4 over 4x plus 20. Okay? So in this case, so just copy first the numerator and then factor out the denominator. So we have the common factor between 4x and 20. You're right. The common factor here is 4. So for applying the first type of factoring technique that we have using the GCF or GCMF, 4x divided by 4 is x, then 20 divided by 4 or positive, so we have here positive 5. And then as you have factored out the terms or the given terms or polynomials that are factorable, so you may now proceed with dividing out or cancelling out the common factors. So you will have your 4 divided by 4 is 1. So you will left on the numerator with 1 all over x plus 5. There we have the simplest form of 4 over 4x plus 20, which is 1 over x plus 5. Okay? For the next example, for example, we have 3x all over 3x squared plus 12. Yes, you will just have to copy the numerator. Then the common factor of 3x squared and 12. Yes, you're right. It is 3. So 3x squared divided by 3 is x squared plus 12 divided by 3 is 4. Okay? So this time, you may cancel 3 because they are already factors. So again, you have to take note that only factors are cancelled, not terms. So on the numerator, you have left with x, and on the denominator, you have left with x squared plus 4. So that's why you have x over x squared plus 4. But if we have 3x over 3x squared plus 12x, you have again to take note that only factors are cancelled, not terms. So for example, I have here x. You may say that it is already the same with the previous example. No, because I have already here x. So we have here to copy the numerator and then factor out again the denominator. This time, your GCMF is 3x. So before or earlier, we have only 3 because the second term is only 12. But this time, the second term is 12x, so that's why the variable x is common on the first term and the second term of our given binomial denominator. So we have here 3x squared divided by 3 is x, then 12x divided by 3x is 4. So that's why you have here, again, to cancel out the common factors or divide out the common factors. So 3x, when we divide it by 3x is 1. So that's why you will left with your numerator 1 and then you have your x plus 4. In case that you answered x plus 4, so that is different from 1 over x plus 4. Again, the final answer is 1 over x plus 4. Okay. So how about if we have binomial numerator and binomial denominator like this? Okay. So this time, you are going to factor the numerator first. Okay, yes, applying the GCMF. Yes, you're right. The common factor here is 3. So 6x divided by 3 is 2x and 15 divided by 3 is 5. Correct. Then on the denominator, we have the common factor which is 4. Correct. And then 8x divided by 4 is, you're right, 2x. Then 20 divided by 4 is 5. Okay, I hope you can follow. And then, divide out the common factors. So, as you have seen, they are common, 2x plus 5. So, this, if you are going to divide them by themselves, so you have 1. So, therefore, 3 times 1 is 3 over 4 times 1 is 4. That's why the simplest form of this is 3 over 4. Okay, I hope you got it. And then, what if we have the binomial and trinomial? Okay. For example, I have here x plus 5 over x squared plus x minus 20. You have to take note of the numerator x plus 5, binomial. Do you think there are common factors between x and 5? Correct. They are not having common factors. So that's why they are already prime. So since they are already prime, so you will have your x plus 5. And on the denominator, since we have here trinomial, and I hope you recall this as under our previous topic, factoring quadratic trinomials, where a is equal to 1. And since our last term is negative, so that's why your factor should be x plus blank and x minus blank. And since our middle term is positive, your bigger number should be on this side, on this sign. Okay? So, what do you think of the factors of 20 that we are going to use? Correct. So, you have positive 5 and negative 4. Again, for you to check if you have this correct factors, x times x is the product of the first term, x squared. Then, positive 5 times negative 4 is negative 20. And using the product of the means and the extremes, so we have here 5 times x is, let us use this side as our scratch, 5x. Then, x times negative 4 is negative 4x. So, when we combine, it is positive x. So, it is correct, or it is the same with our middle term. So, that's why we have the correct factors, x plus 5 times x minus 4. Then, as I have said, after factoring, divide out the common factors. So, we have here 1. And then, you will have on the numerator with 1 over the denominator is x minus 4. So, this is our simplest form. Okay, so I hope you get it. And for the next example, let us have trinomial. Sometimes on the numerator and on the denominator, we have binomial. Okay, so this time, we have again to factor out. Again, after finding the GCF, factor out, and then divide out the common factors, and then simplify. Okay, so we have the factors of x squared plus 3x plus 2 will be correct. X plus 2, thank you for answering. So, we have here x plus 2 times x plus 1. And then, since it is, so ito ay under ng ating lesson, under quadratic trinomials. And our denominator is under our topic DOTS. Yes, bilis kapag DOTS. So, we have here x plus 1 times x minus 1. And then again, find for the common factors, divide them out. So, x plus 1 divided by x plus 1. So, this will become 1. And on the numerator, we have left with x plus 2 over x minus 1. So, this will be our simplest form. You may think that, why did I not cancel x here? So, I have told you earlier that you are going to cancel only the factors, not terms. Again, only factors. Sabihin nyo, paulit-ulit. But again, you have to take note of this. Only factors are cancelled. Okay, sorry for the penmanship. Not terms. Because on our previous answer, we have here, if you are going to recall, we have here x plus 2 over x minus 1. If you are going to recall, x plus 2 earlier is a binomial factor inside the parentheses. And also with x minus 1 in the parentheses also are binomial factor. So we may say that x here is a term. And x here is a term. So that's why you cannot cancel them out. That's why again, your final answer is already x plus 2 over x minus 1. Okay? So, I hope you get it. And, for the last example, let us have x squared plus 7x plus 12 all over x squared plus 8x plus 15. So, very simple. It's my favorite topic in factoring. Factoring quadratic trinomial. So, I have here a is equal to 1. So, since the last term is positive, the middle term is positive. So, therefore, you may have x plus blank times x plus blank. And since I have here the term 12 and it should have the sum which is 7, so I have to use no other than positive 4 and positive 3. So the binomial factors will be x plus 4 times x plus 3. All over, same with the denominator, factor out 15. So we have here x plus 5, and then x plus 3, because if we are going to combine the product of the outer terms and the inner terms, it is equal to 8x. And then, factor out the common factor. So, obviously, so we have here 1. And we have left again with x plus 4 over x plus 5. Again, you cannot cancel out x here because x here serve as term. Okay? So, again, only factors are cancelled, not terms. So, I hope you learned something about this video. So, that's all for this morning. Goodbye!